All right, hello. Today is lesson 3B, still graphing linear equations. You'll notice that we'll be basically doing the same thing through this whole unit, graphing linear equations. Students will be able to discuss varied methods of graphing linear equations, and this is important for many topics next year and this year. Number one, let's look at this first equation to graph. So they gave us the equation y equals 2x plus 1, and so we need to graph this. In order to graph it, we can find the unit rate, the initial value, and some points. So let's think, if x were 0, we would plug in 0, and we'd get 0 plus 1, which would be 1. And that's our initial value. So our initial value is 1. Which down here, notice we do have the full graph to use today. Down here means this graph is going to start at 0, 1. So put your first point down there. Then we just go through getting more points so that we can see the rate, so we can see the change. Remember, the unit rate is how it changes. So the unit rate is the change. And remember, to find the change, we look for the change in y over the change in x. We look for how y is changing, and we put it over how x is changing. All right, so if we were to plug in 1 here, we would have y equals 2 times 1 plus 1 would be for this value here. So 2 times 1 is 2 plus 1 would give us 3. How about the next one? 2 times 2 plus 1. 2 times 2 would give us 4 plus 1 gives us 5. How about 2 times 3? 2 times 3 plus 1. 2 times 3 would give us 6, plus 1 would give us 7, and it looks like they just want one more. 2 times 4 plus 1. 2 times 4 would give us 8, plus 1 is 9. All right, so we have a bunch of points to plot now, and so we can go ahead and transfer those down here. 1, 3 means start at 1, go up to 3, so that's right there. 2, 5 is going to be up here. 3, 7, 3 up to 7, and then 4 up to 9. All right, but that's not the only direction this line goes, and I will go ahead and use a little ruler there to make sure this line is straight. If I wanted to continue this line farther, instead of just going that way, I can actually extend this down because that would be just the other part of the line. So that tells me that there's more answers to this equation. There's actually an infinite amount of answers here because this line just keeps going. That's why we put arrows there. So if I were to just keep plugging in numbers, I would get more answers for y. So this line actually does keep going. All right, so now the question, what was the unit rate? Remember, that's how it's changing. So this is changing by going up 2, or in other words, they're adding 2 every time. Going up 2 every time we add 1 to the x. Every time it's adding 1 to the x. So it's adding 2 to the y for every 1 for x, 2 to the y for every 1 for x, 2 to the y for every 1 for x, and so that tells me our unit rate is 2. Well, hopefully you're starting to notice the way these equations are set up. I see my starting value over here. My starting value, my initial value showed up right there in the equation by itself, and the way it changes shows up right here in front of x because that's how y is changing for every x. So for every x, y is going up 2, so that's why we have a 2 there in the equation. All right, let's check number 2. So notice they didn't draw in the line here. This little graph right here was meant for number 2, which is y equals 14 minus 2x, that we don't see on the other page. So that little weird graph there is meant for this one. We're going to start this one with 14 and then subtract 2 for every x. So anytime you're given an equation to graph, you want to start with some points. All right, so I'm going to start with the easiest point ever, 0. All right, if I were to plug in 0 to this equation, and we did see this one yesterday, I would have 14 minus 2 times 0. So that means I would have 14 minus 0, which is just 14. So that tells me this graph is going to start at 0 up at 14. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So it's starting up there at 14, and then I just add in more points to check. Let's try 1. So if I were to plug in 1, then I would have 14 minus 2 times 1, which would be 14 minus 2, which gives me 12. All right, so that means from 1 it goes up to 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. That's right there. All right, let's check another point. Let's just do a couple more points. How about y equals 14 minus 2 times 2 this time? So that means I'd have 14 minus 4, which gives me 10. So from 2, this graph goes up to 10. From 2, it goes up to 10. So from 2 on the x, it goes up to 10. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. There it is right there. I'm starting to see this linear pattern. Let's just try one more. Y equals 14 minus 2 times 3, which means I'd have 14 minus 6, which means I would get 8. So from 3, this is going to go up to 8. 1, 2, 3, 4, 5, 6, 7, 8. All right, and you might have noticed this little pattern occurring with our points. I'm going to use my ruler, and I'm going to connect those points now. And you should see that this has a downward motion. This one is changing by going down. And we might have noticed this pattern. For every time I move over for x, I'm going down 2 for y. So see this down 2 over 1 for x, down 2 on the y, 1 for the x, down 2 for the y over 1 for the x. So every time I'm moving down this line, it's the same thing. So here, our initial value is our starting point. It's where x is 0. So our initial value here is 14. And we notice it shows up there in the equation. By itself, no x connected to it. So the initial value is 14. That shows up right there. That's before we start changing the x. And then our rate is how it changes. So it's the change in y over the change in x. Change in y over the change in x. So how is y changing? Well, from 14 to 12, it went down 2. From 0 to 1, they added 1. So that's how we get that our rate is -2. So notice, our rate is -2 because it's going down 2 for every 1 on the y. It's going down 2 for every 1 on the y. And hopefully you can see that in the video. It's not showing up too well, but that is a -2 because it's going down 2 for every 1 on the x. Down 2 for the y, 1 for the x. Down 2 for the y, 1 for the x. Okay, and we see that show up right here by the x because that's how the x is changing. So it starts at 14 and then changes by going down 2 per every x that's added. All right, I am going to skip over y equals -3x plus 4 and y equals 5x minus 7, number 3. And we're going to go over here to number 4, y equals -2x minus 3. All right, so let's go ahead and start plotting some points on this. If I plug in 0 here, remember that means I would have this equation, but in place of the x, I'm going to plug in a 0. All right, so that tells me for this one, I have -2 times 0 minus 3. -2 times 0 minus 3. So that means I would have 0 minus 3, and 0 minus 3 is -3. All right, so this one starts down in the negatives. Hopefully that's never your bank account. But this is starting down in the negatives. I can already see my initial value is -3 because that's where the x is 0. Remember, our initial value is where the x is 0, and we see that show up in the equation right there. That's the one without the x. All right, now let's look at how this changes. Remember, our unit rate is how it's changing. So let's try -2 times 1 minus 3. -2 times 1 is -2. And if we take away 3 from -2, we end up at -5. So this one has where x is 1, y is -5. So it looks like this graph is going down. Let's try the next one. -2 times 2 minus 3 would give us -4. Take away 3, which gives us -7. Let's go ahead and fill in our other points. -2 times 3 minus 3 would really mean -6 minus 3, which gives us -9, and -2 times 4, take away 3 would give us -8, and take away 3 would give us -11. All right, so now we have all those points. We, yes, only use some positive x's, but that doesn't mean this doesn't go the other direction as well. 2 goes down to -7, 1, 2, 3, 4, 5, 6, 7. 3 goes down to -9, there's 7, 8, 9. And 4 would go down to -11, which is off the graph a little bit down there. All right, I'm going to use my ruler to connect my points. Let's connect those. And we see this slope goes down. We see that this is sloping downwards. All right, because that's a negative change. All right, so what's our change in y? So change in y over change in x. our change in y, it's going down 2 each time. Every time it's adding 1 for the x. And so again, our unit rate is going to be -2. -2 for the unit rate here. That's because this is going down 2 for every 1 on the x, down 2 for every 1 on the x, down 2 for every 1 on the x, down 2 for every 1 on the x. That's how it's changing. And so that's our unit rate. And we see that unit rate again show up in the equation right there attached to the x, because the y is changing by going down 2 for every x. All right, let's look at one that has a fraction, dun, 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 so that we can see what to do with those. All right, now notice they gave us some numbers here that aren't very fraction friendly, so we're going to change some of those numbers, but 0 is friendly for everything, so let's see what we get from that. So if we plug in 0 for x, 2/3 times 0 minus 1 just gives us 0 minus 1, which is -1. So that one's not so bad. We start this graph at -1, so our initial value is -1, and we can see that show up in the equation over there without an x attached. All right, remember our initial value is where x is 0. That's our starting point. Now we see how it changes. So instead of plugging in a 1 here, because that would give me 2/3 minus 1, instead of plugging in a 2, because that would give me 4/3 minus 1, let's plug in a 3. All right, so let's try 2/3 times 3 minus 1. Now I do that because remember, we can cross reduce these. And so 3 cancels out to a 1, 3 cancels out to a 1, and that ends up with just 2, whole number 2, minus 1. 2 minus 1 is nice and easy, that's 1. So that tells me over here on the graph, it's going to go from 3 up to 1. That's our next point. All right, I am not going to use 4, I'm not going to use 5, but I will use 6. Let's see what happens when we use 6. Why did I pick 6? Because 6 is a multiple of 3, and I know I can cross out that bottom number if I pick a multiple of it. So 3 cancels out to a 1, 6 crosses out to a 2, 2 times 2 is now just whole number 4, and 4 minus 1 gives us 3. So there's our next point. We'll just use that one next. I'm going to continue this table down here. So that's a 3. I don't know if you can see that. Let's write that better. 4 minus 1 gives us 3. So 6 goes to 3. 6 over here goes up to the 3 right there. All right, all I really need are a few points so I can line up my ruler and plot that line. All right, so let's look at the change this time. So the change is a little bit different this time. From -1 to +1, it went up 2. All right, so my change in y is it's adding 2 on the y for every, well, it's not 1 on the x this time. It added 2 on the y for every 3 on the x. Because notice from 0 to 3 adds 3. So that tells me my rate of change, my unit rate, is 2/3 this time. So let's check that on the graph. That means for every 2 it's adding on the y goes up 2, it's going to add 3 for the x. And yeah, that gets me to my next point. For every 2 on the y, there's 3 on the x. Yeah, that gets me to the next point. And if I were to continue that pattern, 2 for the y, 3 on the x, then I would continue finding more points on this equation, on the graph of this equation. So we see this unit rate, 2/3, again show up right there in front of the x in our equation. All right, last one, let's look at number 7 on the back, a graph that's already done because you guys were having a hard time with that the other day. So this time we're going to use the graph. Where does this graph start? Well, it looks like it starts right there where y is at 1. Okay, so our initial value, remember, is where x is 0, and then our initial value is next to that. So x is 0 where y is 1, so our initial value is a 1. From there, I just look for some good cross points. It looks like maybe 2, 2 is a good cross point, 4, 3 is a good cross point, 6, 4 is a good cross point. So how is this graph changing from each of those points? Well, it looks like the y is going up. So let's write it up here for unit rate. We don't need to worry about regular rate right there. So for the change in y, it looks like it's going up 1 for every 2 on the x. Up 1 on the y for 2 on the x. And so that's going to be our rate. So for our equation, we would write 1/2 x plus 1. There's our rate and our initial value.